Hi again. So I briefly defined what is the joint probability distribution and what is the marginal probability distribution. Let's think about them in our example. In our example, we have these 2 by 2 matrices, 2 by 2 probability distribution, and this is the joint probability distribution. And if you want to calculate the marginal distribution from this joint, for example, if you want to calculate a marginal distribution for the health insurance coverage, then what you do here is you have to sum the probability across columns throughout the row. So add 13.8% plus 19.98%. So add these two probabilities. Then you get 33.69%. This probability includes everyone who is not covered in an health insurance, regardless of their gender. So this summation deletes the information about gender. You only care about the health insurance coverage, but I don't care about gender. So in the end, you have 33.969% for the uncovered. And similarly, if you add these two numbers, again, you are adding the probabilities of female covered and the male covered. So in the end, the sum equals to the probability of those who are covered, regardless of gender. Therefore, you have these two probabilities after throwing away the information about gender. So these two numbers do not include any information about gender. So this is the marginal distribution for health insurance. Take these two numbers and write that as a 2x1 probability distribution table. This is, and you may do the same thing if you add 13.8% plus 36.72%, then you get 50.52%, which is the probability of female regardless of health insurance coverage. So by adding these two numbers, you are deleting the information about health insurance variable. Similarly, if you sum in this column, then you get the probability of male. So these two probabilities make a marginal probability distribution. So for gender, it is about one variable. So as you have seen, it is easy to calculate the marginal distribution from the joint distribution, because the joint distribution has information about two variables, gender and health insurance at the same time. So when you have two informations, deleting one of them is easy. It is just summation. So you are deleting one variable, so it is not a big problem. And you have these two marginal distributions. But what we have to think about is whether you can calculate the probability of, you can calculate a joint probability. For example, if you are interested in the probability of women without health insurance coverage, can you calculate this probability only from these two marginal distribution tables, marginal probability distribution tables? Think about this. The video is a little bit short, but I'm going to stop here. If you think you can calculate the probability, try, do the algebra. And if you think you cannot calculate the probability, think about why. Why, or make up your rationale. I will continue in the next video like next video will start with on the answer to this question. Think about this. It's a very interesting question.